Hey, suppose you have a delivery today and this is your city. You live in this city and this is your city's boundary. And this is where your delivery person is right now. So how do you know if the delivery person is inside the city? These are just coordinates. So how do you know if the delivery person is exactly inside the city? That is what we are going to see today. We're going to learn about bounding box and point in polygon. So these are the contents of a video. We'll look what bounding box is. We'll see the raycasting algorithm, and finally we'll code it. Okay, so bounding box. Okay, so these are the coordinates of the polygon. Okay, that is a city. So now we have extended the x coordinates those points. Okay, so you can see that these these lines, these x lines. So your polygon fits inside these x lines. Okay, so these are your boundary limits, x boundary limits of your polygon. So this is your min x and max x. Similarly, for these are your y coordinates. Okay, they have been extended. Now, similarly, they have a minimum y and a maximum y. Okay, so if I take these lines and these limits and superimpose them on each other, you get this. You see, there is a box formed out of those intersections. This box is called as a bounding box. This. So what bounding box says? A bounding box is the smallest rectangle that contains the entire polygon, and the bounding box should be uh, parallel to the axis. Okay. So this is the smallest box. Okay. So now if I take the point, now this is your delivery part of the question. Now I want to see if that point lies inside the polygon. Isn't it better if I see that does it lie inside these 4 points, these box coordinates? Okay, that will be easier, right? So we know that it does not lie inside the box, and clearly we can say that it is outside. But what if this point was here? Now it bypassed our initial filter. So what do we do now? Now that takes us to our second topic of video, is raycasting algorithm. So let's take a more complex map now. Okay. Now this is the bounding box of this map, of this polygon. Okay. So now let's take a point here. You see, this is inside the bounding box. So now the challenge is to tell if it is inside the polygon or not. Now, the ray casting algorithm says that you take the point as the origin, the point into consideration, and you cast a ray to the right side indefinitely. And you count the number of intersects it makes with the polygon. So let's do that. We casted a ray to the right side and we count the number of intersections. So this is one and this is the second intersection. And we know it's outside. Okay, let's just keep that in mind. Two intersections and lies outside. Next point. Now the point lies inside. Another ray casted intersects at 3 points, 1, 2, and 3. And we know it's inside. Okay, so far 2 points outside, 3 points inside. Next point. Another point lying outside. Let's cast the ray. You see here, first intersection, second, third, and fourth. So, what do we see? There's a pattern. Now, the ray casting algorithm says that if the ray intersects the polygon at even number of locations, then the point is said to lie outside the polygon. So, for example, if the point intersects at 2, 4, 6, 8 points, then the point definitely lies outside. Otherwise, that is, if it intersects at 1, 3, 5, that is at any odd number of points, then it lies inside the polygon. So, but what about this case? Now, say we cast a ray from this point. You see, there is one intersection here, but what about this point? Is that an intersection? No. This point, you see, the ray just passes through the point. Okay, so it is not counted an intersection. Similarly, if the ray just grazes an edge or is collinear with an edge or just crosses a point, which is this case, then that is not counted as an intersection. So in this case, there is just one intersection. So it's an odd number of intersection, and that is where the point is inside. Okay. So to sum it all, the algorithm goes like this. You start, you create the BBOX, that is the bounding box of the polygon. Then you check, is the point inside the bounding box? No, then that is clearly outside. But if it is inside the bounding box, then you implement the recasting algorithm. Then what number of intersections do you get? Are the number of intersections even? Then that means that the point is outside here. Else, for odd number of intersections, it is inside. So now let's look at code. But before that, we'll take an example. Okay. So here's another example. So these black points that you see are the city boundaries. Okay, the polygon is under consideration. And the red points are the points to examine. So let's call them delivery partner locations. So now you can see this point, this first point is inside. This is the second point. This is outside. You can see this is the boundary. So this point is definitely outside. And this point is also outside. So what output do we expect? We expect that the first point is inside, second is outside, and third is also outside. Let's look at the code. So I have given the same coordinates. You see, I have made the polygon using the same coordinates and see that the first and the last coordinate are the similar. So we make a closed line string. That is why it's a polygon. So the code is very simple. We make the city, yeah, city polygon. We make it bounding box. Then we declare the locations to examine. These are the three locations in that order. Then we iterate through the locations. We check if the location, if the bounding box, if the location is inside the bounding box. If it is not, then we directly say that it is outside. Okay, no further checking required. But if the point is inside the bounding box, then we check if it is actually inside the polygon by the point in polygon method. Okay, that's it. So let's run. Yes, 4 comma 5. That is the first point is inside, second outside, and third outside. Those are the 3 points here: inside, outside, and out. So that's it, guys. That's all from this video. And we saw we saw the starting of algorithms today, and we'll now see more of algorithms. We'll not just see them, we'll visualize them. So stay tuned for that. Thank you.